today's presenter Sangam Dhital, representing Preciousness and Academy, and today I am presenting on the topic pressure. First of all, let me tell you about pressure. Can anybody define pressure? Okay, let me tell you. Pressure is the perpendicular force acting per unit area. For example, if this is a ground surface and if certain force is applied on that area, then it is said to be pressure. Now, we know that pressure is exerted by liquid also. So, liquid pressure is the pressure exerted by the liquid on the body. Let's say it's a container and it contains fluid and it's a body. And now, the pressure exerted by this liquid in all direction to the object is known as its liquid pressure. Now, by the definition of pressure, we have force. Pressure equals to force by area. And now we know that force equals to mass times acceleration due to gravity. So we can write mg by a. So again we can write. We know that density equals to mass by volume. From this relation, we get mass equals to density times volume. And now, so we can write mass equals to density times volume times acceleration due to gravity by area. And now again, volume equals to length times breadth times height. And we know length times breadth means area, so volume equals to area times height. So instead of volume, we can write area times height. So the area term is cancelled and we got pressure equals to dGH. Here P refers to liquid pressure, D refers to the density of the liquid, G refers to acceleration due to gravity, and H refers to height, or we can say depth of the body. Now, here I have made a mind mapping, and let me start from the Pascal's law. Now, pressure was first developed by French scientist Blaise Pascal, so it's he made a law on his name. Pascal's law states that when a vessel containing liquid is applied with certain amount of force, then equal amount of pressure is exerted in all directions. For example, this is a vessel and it contains fluid inside it. Now, when we apply certain force on this vessel, equal amount of fluid is transmitted in all directions. It means the liquid pressure is equal in all directions. And now, let's talk about the devices that runs based on Pascal's law. Wherever there is the word hydraulic, we can say that it works based on Pascal's law. For example, hydraulic brake. Hydraulic brake is a kind of braking system usually used in the four-wheelers, which is made based on the liquid pressure. And now let's talk about thrust and upthrust. Thrust is the perpendicular force acting on the body. Let's say this is an object A, and now certain amount of force is applied on this body. Now when that force is perpendicular to this body, then it is said to be thrust. But now it's the turn of upthrust. Now, in this container, there is fluid and an object is immersed inside this fluid. Now, certain liquid pressure is exerted equally in all directions. Now, this resulting force given by the fluid to this object from the downward side is known as upthrust. It means that it is the resulting force acted on this body by the fluid. It is also known as buoyant force. And now, we know that density is the heaviness or lightness of a body. Simply, we can say that density is defined as the ratio of mass and volume. We know that D equals to m by d. So, when we keep the mass constant, then the volume may decrease or increase. In this condition, when the volume is increased, the density of the substance decreases, and when volume of body is decreased, density of body increases. So we can say that density of the body is inversely proportional to volume of that body. And similarly, when we keep the volume constant, we can get the observation that density becomes greater when the mass is greater, and density becomes smaller when the mass is smaller. So we can say that density of a substance is directly proportional to the mass of the body. Now, relative density. Relative density can be defined as the ratio of density of any substance to the density of water at 4 degrees centigrade. It is also known as specific gravity. We know that the density of pure water at pure water is 1000 degree, 1000 kilogram per meter cube. This value is constant at 4 degrees centigrade, so we need to keep here 4 degrees centigrade. Wherever specific gravity comes, it means that relative density is going. And now the most important thing, Archimedes principle. Archimedes principle was propounded by great scientist Archimedes, and it is termed after his name. And Archimedes principle states that when a body is completely Now, here are two figures. In first condition, there is a body A, and it is partially immersed into the fluid. And now, in this condition, this body displaces certain amount of fluid, and let's say that fluid is collected in another container. And in second case, the same body A is completely immersed inside the liquid, and it also displaces certain amount of fluid, and it is also collected in the beaker. Now, in both of these conditions, the weight of this liquid displaced is equal to the weight of this object. It means weight of body A is equal to weight of liquid displaced. And now, at this condition, we can say since upthrust is the resulting force given by the liquid to the object, we can say upthrust is equal to the weight of liquid displaced. It means the force acting on this body from the downward direction is equal to the weight of this liquid displaced. And now we have a formula. Upthrust can be calculated by the formula thrust equals to weight of object in air minus weight of object in liquid. When the apparent weight and actual weight is given, we can apply this formula to find the upthrust or the buoyant force. And now we know the upthrust is a kind of force. So the formula to calculate force of the body is mass times acceleration due to gravity. Let's say the mass of this object is m1 and mass of this liquid displaced is m2. Now we can write m1 times g equals to m2 times g. M refers to mass and g refers to acceleration due to gravity. Now the value of acceleration due to gravity is constant or same on the both cases. So this term is cancelled and we got m1 equals to m2. By this we can say that the mass of the object is also equal to the mass of the liquid displaced. Again we know that density equals to mass by volume. We got mass equals to density by density times volume. So we can write d1 times v1 equals to d2 times v2. From this relation we got another new relation, that is the product of density and volume of this object is equal to the product of density and volume of this liquid displaced. And now let's talk about law of fluorescence. Law of fluorescence is similar to Archimedes' principle. This figure is also same as that of Archimedes' principle. Here we have a body, and it's just the difference is it is floating in the liquid. Now in this condition, when the we already studied that this body displaces some amount of fluid. So according to law of fluorescence, when a body floats in a liquid, then the weight of this floating body is equal to the weight of this liquid displaced. It means this one. Weight of the floating body is equal to weight of liquid displaced. And okay, so the portion of liquid pressure is finished. Now let's talk about atmospheric pressure. Atmospheric pressure can be defined. We know that liquid pressure is the pressure exerted by liquid, and now atmospheric pressure is the pressure exerted by air on the ground surface of the earth. Now this liquid pressure is measured by the unit Pascal, since it was derived by Blaise Pascal. So, but in case of atmospheric pressure is measured in mm of Hg. Why is it measured? Because 1 atmospheric pressure is defined as 1 atmospheric pressure is the pressure exerted by 760 millimeter of mercury in ground surface of 1 meter square area. And now we know there are many devices which work based on atmospheric pressure. We use fountain pen that also works based on atmospheric pressure. But now here we read 3 topics, 3 devices that works based on atmospheric pressure. Let's talk about mercury barometer. Barometer is a device which is used to measure the output. And now, barometer is same as that of thermometer. Here I am laying a rough figure of barometer, and now here is a small structure tube, and in this barometer certain scale is given, and inside the tube of that barometer mercury is filled. Now when the atmospheric pressure is more, then the level of mercury decreases, and when the atmospheric pressure is less, the level of mercury increases. By this we can say that atmospheric pressure is inversely proportional to I. And this barometer works as the same principle of that of thermometer. That is, it expands on heating and contracts on cooling. And the next one is syringe. Syringe is a device usually used in medical field to inject the medicine inside the body of patient. And now the cylinder mainly contains two parts. They are cylinder and piston. The needle-like structure of the syringe is known as piston, and the remaining hollow structure is known as cylinder or syringe. Now, this syringe works based on two processes. They are cooling the piston and pushing the piston. Before this, let me tell you one relation. The atmospheric pressure is inversely proportional to the volume of the body. It means more the volume, less the pressure, atmospheric pressure, and less the volume, more the atmospheric pressure. Okay, now let's look at this figure. Here I have made a figure of syringe, and this part is piston, and this remaining part is cylinder. This part is piston, and this is the cylinder. Now, when this one is needle. Now, when this piston is pulled upwards, then the volume of part A increases, by which less atmospheric pressure is gained by this area. So, it helps to pass the liquid from this part A decreases, by which atmospheric pressure increases in part A. By this, the liquid can easily enter inside the body of patient through the by the help of needle. Now the next device which works based on the atmospheric pressure is air pump. Air pump is a device which is used to fill the air in the bicycle's wheel or any other vehicle's wheel, balloons, balls, toys, etc. It also works same as that of series, only its structure is bigger. It also works on two processes. They are pulling the piston and pushing the piston. Now, this part of the air pump is piston and this part of the air pump is cylinder, and this knot is a valve by which air flows through to the object. Now when this piston is pulled upwards, then the part of this volume, then the volume of this part A increases, by which less atmospheric pressure is gained by this part A. At this time, the valve of bicycle's wheel is closed, by which it blocks the passes of the air flowing from A to B. Now again, when this piston is pushed downwards, then the volume of part A decreases and part B increases. By this, the air from part B to A passes to the bicycle's wheel because more atmospheric pressure is gained by part A. At this time, the valve is opened by the atmospheric pressure gained by part A, and it enters the bicycle wheel, and thus air is filled in that object. And the last portion is air water pump. Now, water pump is a kind of device which is very helpful for extracting water from the water source. It is same as that of air pump. Only it consists is of handle, cylinder, piston, rod, spout, and two valves. Now, this water pump works by the two processes. They are downstroke and upstroke. Downstroke is the process of lifting the handle up and pushing up the piston down, and upstroke is the process of pushing the handle down and pulling the piston up. So when this handle is lifted up, then this part, that is piston, is pushed down, by which valve is sorts off, that is valve A gets closed and valve B gets opened, by which water can flow from A to B. And now that process is known as downstroke. Now when this handle is pushed downwards, then this part, the piston, is pulled upwards. At this time, valve B gets closed and valve A gets opened. By this, the water from the source can pass easily to the part A, and water is collected in that part, and the water that flowed from A to B gets comes out from this spout. In this way, water pump works. So these are all the topics that we need to study under pressure. What do you mean by downstroke? Details of what is downstroke?
When the handle is lifted up, the piston goes down. When the handle is lifted down, the piston rises up.
Should I revise it?
When the handle is pushed down, the piston goes.
That is the upstroke. Downstroke means when this handle is lifted upwards, piston is pushed downwards. Till
When the handle is lifted upwards, the piston goes downwards.
Minutes? Okay, now question answer session. You have to ask the questions to Sangam, he will answer. Which turn now? Ravi?
Why air is not used instead of water in hydraulic machine?
sorry.
Why is air not used instead of water in hydraulic machine? Only. Why is air not used instead of water in hydraulic machine?
I told you hydraulic means that type of machine which works based on liquid pressure. So how can we put air on that?
Next question. Okay, Jimin, do you have question? Jimin.
Sorry.
It is easier to lift our lips in water than in water.
In water, the okay. example, tell me where is the value of acceleration due to gravity? More and less. Okay, this is Mount Everest and this is Pascals Law. Where is the value of acceleration due to gravity? Now, as you told that value of small g is more in this region than in this region, and your question was it is easier to lift our limbs in water than in the air. In sea level, the value of acceleration due to gravity, that is small g, is less than in comparison to the value of acceleration due to gravity in air. So, by which weight becomes directly proportional to acceleration due to gravity, and hence we feel less weight in water than in the air. So, because of this, because of acceleration due to gravity, the value doesn't remain constant and it differs from place to place. So, it is easier to lift our limbs in water than in the air.
Okay, thank you very much. Sangam, do you have anything to say?
Thank you for this.
Thank you so much, my science sir, Ishwar sir, for giving me this opportunity to present about this chapter. I was in confusion about this chapter, but today I think I present nicely.
Thank you very much. So, very wonderful performance.